Okay, so we're ready to move on to the third section of our studies here, and we're actually going to start looking at Ohm's law. We're going to start looking at the resistive nature of circuits and how it will lead us to the other two fundamental components for Ohm's law. So the relationship of current, voltage, and resistance, looking at current calculations, voltage calculations, resistance, and then in the end, we'll take a little bit of a look at troubleshooting, although that's part of your lab class. We'll hit it just at a high level. So we're going to look at, for the chapter objectives, Ohm's law, some circuit applications for each of the components, the proportional relationship between voltage, current, and resistance, and then describe, again, just an overview of troubleshooting. So, in each of these, we're going to describe how voltage, current, and relationship are related, how they functionally interrelate between voltage, resistance, and current, look at some graphical methods, and then explain why current and voltage are linearly proportional. Ohm determination experimentally that if the voltage across a resistor is increased, the current through the resistor will also increase. And likewise, if the voltage is decreased, the current will decrease. For example, if the voltage is doubled, the current will double. If the voltage is halved, the current will also be halved. This relationship then can be seen here if we look at these little current and voltage meter relationships. In the first one, we have the voltage less and less current. Over here we can see more voltage, more current. And so as we go through the mathematical relationships, this is going to become more apparent to you. Ohm can also be determined if the voltage is held constant. Less resistance results in more current. Also, more resistance results in less current. So again, for example, if the resistance is halved, the current doubles. If the resistance is doubled, the current is halved. This concept is illustrated again by the meter. So you can see we add a resistor in here, a 10 ohm resistor, a 20 ohm resistor, and you can see from the graphical representations of these meters what's going on here as we change the voltage and the current. Ohm's law states that current is directly proportional to voltage and inversely proportional to resistance. And this makes a lot of sense if we just look at the mathematical relationship. If we use the form of Ohm's law that says the current is equal to the voltage divided by the resistance, we can see that the current and the voltage are both in the numerator, so they are directly proportional. But the resistance is in the denominator, so they're inversely proportional. So as resistance goes up, current goes down. As resistance goes down, current goes up. So where current, I, is in amperes, the voltage is in volts, and the resistance is in ohms. And you notice they use both forms here. You can spell out ohms, or you can use the Greek symbol for ohms. You need to get used to using that Greek symbol whenever you identify our values of ohms, to always tag ohms onto the value. For a constant value of R, if the value of the voltage is increased, the value of the current increases. If the voltage is decreased, the current decreases. If the voltage is constant and the resistance is increased, the current will decrease. Similarly, if the voltage is constant and the resistance is decreased, I decreases. So we can see here on the bottom here, we've got two more forms of the relationship for Ohm's law. All three of these are Ohm's law. All we're doing is solving for each of the functions individually. On the first one, I equals V over R, if we move the resistance value out of the denominator and into the numerator on the other side, we now can solve for voltage. Voltage is equal to current times resistance. And then in this case, if we move the resistance into the numerator and the current into the denominator, we have the third form. So you need to get used to being able to manipulate these values. I would suggest you write down and learn one of the versions and then be able to derive the other two from that so that you always know what the relationship is between voltage, current, and resistance in Ohm's law. So Ohm's law describes mathematically how voltage, current, and resistance in a circuit are related. Ohm is determined experimentally if the voltage across the resistor is increased, current through the resistor is also increased. Likewise, if the voltage is decreased, the current will decrease. So these are the first three fundamental things that we need to make sure that we fully understand about Ohm's law as we start progressing through this chapter and through the rest of the course. Ohm's law states that if the voltage is halved, the current will also be halved. If the voltage is doubled, the current will also be doubled. If the voltage is kept constant, less resistance results in more current. More resistance results in less current. And again, you don't have to memorize these things. All you have to do is go back and look at those three relationships, and everything that is said here and here comes directly out of those three relationships. So in our relationship, I is equal to V over R, for a constant value R, if the voltage V is increased, the value of I also increases. Why? Because they're both in the numerator. They're both proportional. If the value of V decreases, the value of I decreases. If the voltage is constant, the resistance is increased and the current decreases. If V is constant and the resistance is decreased, I increases. Okay? Do you want to prove this to yourself for each of these cases? Stick some simple numbers in here. Keep them really simple. Make the voltage 100. Make the resistance 2. Or make the resistance 200. However you want to do it. Make it real simple and run through each one of these examples, each one of these steps, and prove to yourself that that is exactly true. Okay, for the other form, voltage is equal to I times R. Here we have a straight product. If you calculate the voltage, you know the values of the current and resistance. You're multiplying an amount of resistance times an amount of current. Let's say 10 times 100. You can see the voltage then becomes 1,000. And in this last one, the formula for resistance is equal to voltage over current. Again, you can calculate the resistance if you know the values of voltage and current. So in this case, Ohm's law defines how three basic quantities are related. So what are these for current, voltage, and resistance? They're each of these relationships. Write these values, write these definitions down in a binder, and keep these handy so that as we move along through the course, you can rely back on them without having to do a bunch of digging through the textbook to remember and get these ingrained into your knowledge base. Okay? So the last two say that the current increases by a triple voltage if we triple the value of the resistor. If the voltage is a fixed resistor, it's cut in half. Okay? Again, I urge you to sit down and put some values in here and prove this to yourself. So next we will look at some calculations here. If the voltage is fixed across a resistor, you can measure a current of 1 amp. If you replace the resistor with one that's twice the value, how much current will you be measured? So voltage is equal to I times 2 times the R. Substituting for the voltage and solving for I, you can see that the current is equal to 1/2 in this case. Okay? Pull out your calculator, pull out your pencil and paper, and prove it to yourself. If a voltage or a current is doubled and the resistance is cut in half, again, you can look through the relationship. Just apply the values to the relationship. Double the voltage, half the resistance. Gather your terms. So now we have 4 times the voltage divided by the resistance. The current would increase by 4 times if the voltage doubles, and the resistance is halved. Okay, so before we look at any more examples, let's go ahead and stop here and take some time to digest this and get this into our thoughts and make sure we've got good notes on keeping track with this.